Projectile motion benchmark 1. I shoot an arrow with an initial velocity of 95.0 meters per second at an angle of 36.5 degrees. How far away from the target do I have to be to hit it? In this benchmark, you will plug in for initial velocity 95, for theta 36.5, and for gravity 9.8. The calculator will solve the following formula. X equals 2 times initial velocity squared times sin of theta times cos of theta over gravity, which will give you the answer of 880.1 and so on.
Benchmark 2. I shoot a compound bow with a velocity of 125 meters per second at an angle of 15 degrees. How far away from my target must I stand, and how long will it take for my arrow to hit the target? Within this question, we're asking two questions. First, we're going to find the displacement of x, which we will do using the equation x equals 2 times the velocity, which is 125, times theta of cos, which theta equals 15 in this case, times theta of sin, which theta again equals 15, over the gravity, which is equal to 9.8. And when we solve for that, it gives us the displacement of x equals 797. So then to find the time, what we do is use cosine of theta, which is 15, times 125, which is the velocity, and that equals x. And x is in meters per second. Therefore, 121 is equal to 797, which is the displacement in x over the time, and that is equal to 6.5.
Benchmark 3. Instead of shooting an arrow on Earth, I'm shooting the arrow on the Moon. The Moon has a gravity of 1.620. Can you tweak your model so that you can resolve either benchmark 1 or 2 with the new information? We will plug in for initial velocity 95, for theta 36.5, and for gravity 1.620. The calculator will solve the following formula. X equals 2 times 95 squared times sin of 36.5 times cos of 36.5 over 1.620, which will give you the answer of delta x equals 5,327.562.
Benchmark 4. I kicked a soccer ball at 25 meters per second of a two-story building, about 10 meters, at an angle of 67 degrees. How far away from the edge of the building do I need to be to hit a target that's 30 meters away from the building? In order to solve this problem, we're gonna first use the equation displacement of y equals initial velocity of y times time plus 1/2 acceleration of y times time squared. When we plug the variables in, since for this equation we have an initial velocity of 25, we have theta, which is equals to 67, and finally we're given us as well the displacement of y, which is -10. When we plug that in, we're going to get two answers of x. One's going to equal 5.096, and the other one is going to equal -0.400. We know it's not the one that's negative, since displacement can never be negative. So we will proceed using answer number 1, which is 5.096. In order to proceed, we must now find the displacement of x, and when we plug everything in on the equation, we get displacement of x is equal to 9.8 times 5.096, which is the time we find on the previous equation. After that, we get displacement of x equals 49.9408, and from there we must subtract the 30 meters mentioned at the last part of the problem, and from that we get 19.94. Therefore, it would be correct to say that approximately you must be 20 meters away.
Mark 5. Bob shoots his hydro cannon with an impressive velocity of 500 meters per second. If his opponent is standing on a cliff 50 meters above him and he is aiming at a 58 degrees above horizontal, then how long will it take his shot to hit his opponent? For VI, or initial velocity, you write 500. For theta, or the angle, you write 58. And for delta y, you write 50, since he is standing at a 50-meter cliff above his opponent, which will give you the answer of negative 0.1. But time can never be negative, so your answer is 0.1. Attached problem. Imagine you run and jump off a 12-meter waterfall and you jump at 15 degrees with a velocity of 7 meters per second. How far from the waterfall will you land? How long will you be in the air for? For this problem, you insert 7 meters as initial velocity. For delta y, 12 meters. For gravity, 9.8, and for degrees, 15. Your answer will be delta x, negative 2.5, but delta x can never be negative, and the time will be negative 1.76, so on, but time can never be negative, so they both are positive. The calculator works because you insert all the information given. You insert VI, which is initial velocity, theta, which is the angle, gravity, which is most of the time 9.8, and in cases delta y, which is the vertical distance. It works because after inserting all the information given, the calculator uses the formula to give you delta x, or the horizontal distance, and the time.